Assalamualaikum warahmatullahi wabarakatuh. Today I will present mathematical reasoning, polar method. So my name is Muhammad Fahmi bin Mat Zahir and I'm from Maths 2 1 PISMP. We move to the introduction. Polar methods is a technique for solving complex problems which consists of 4 steps, which is understanding the problem, devising a plan, carrying out the plan, and lastly, reviewing the solution. This structured approach not only helps in breaking down intricate problems but also encourage students to reflect on their reasoning process and leading to more effective learning outcomes. By employing mathematical reasoning and problem-solving techniques such as polar methods, individuals can gain valuable skill applicable across various fields from engineering to finance. So without wasting our time, we move to problem statement, which is the question is you are managing a concert ticket sale and you need to distribute 365 tickets equally among group of people. The tickets come in packs of 3, 5 and 7. Your task is to find the smallest number of people such the total number of tickets is distributed without any leftovers. For the first part, we use symbolic representation. Symbolic representation is the use of symbols, equations, and formulae to express intricate concepts, connection, or actions is known as the symbolic method in mathematics and problem solving. So we move to the polar methods, which is step 1, understand the problem. Okay, first, we need to understand the question. The question said that we have 365 tickets to distribute equally. Tickets are sold in packs of 3, 5 and 7. Then you need to distribute all the tickets without any leftovers. So basically, the goal is to find the smallest number of people where each person receives either 3, 5 or 7 tickets such that the sum of the tickets distributed to everyone is exactly 365. So from the question, we basically can translate it into an equation which is 3x plus 5y plus 7z equals to 365, where x is the number of people who gets 3 tickets, y is for 5 tickets, and z is for 7 tickets. So we need to minimize the total of people, which is x plus y plus z, under the condition that the equation holds. So we move to the next step, which is carry out the plan. Using an algorithmic technique or trial and error. So we can find combination of x, y and z that satisfy the equation while minimizing the overall number of people. So since 7 is the maximum ticket size, we assume that z equals to 50. Then we substitute in the 50z. So we got 350. So the remaining tickets, we basically minus it from 365 and we got 15. Now we solve the equation, which is 3x plus 5y equals to 15. And we assume that x is 0 because y equals to 3 satisfies this equation, since 5 times 3 equals to 15. We move to the last steps, which is review the solution. we know that the smallest number of people who can receive exactly 365 tickets without any leftovers is 53. Here is how the tickets are distributed. 0 people receive 3 tickets, which is there is no people that receive 3 tickets. 3 people receive 5 tickets, which is equal to 15 tickets. And finally, 50 people receive 7 tickets, which is equals to 350 tickets. So we sum off the total of ticket and we got 365. So we move to the alternative solution. In the alternative solution, we use an iconic representation. So basically, iconic representation is an illustration that makes mathematical ideas more approachable and understandable for students by using pictures, symbols, or drawings. So we move to the step 1, which is understanding the problem. As we can know, we have 365 tickets to distribute equally. So then we represent all the type of tickets, which is 3, 5, and 7 by color of square. So for the 3 ticket specs, we use green square. 5 ticket spec, we use blue square, and 7 ticket spec, we use yellow square. So we move to the step 2, which is devising a plan. So we need to visualize the combinations. First, we start with the largest pack size, which is we need to minimize the total number of people receiving tickets. Second, we need to keep track of the number of tickets remaining after we distribute each type of pack. And lastly, we need to adjust the number of packs, which is we need to adjust the number of packs as necessary to find the optimal combinations. So we move to the step 3, carrying out the plan. For this part, we divide it into 3 scenarios. So then we move to the first scenario, which is we maximize 7 ticket packs first. So for the first step, we need to start with 50 yellow squares, which is we maximize the 7 ticket. So after we maximize, we represent it into the 50 yellow square, and the total tickets given is 7 by 50 equals to 350. So we minus it from the tickets that are available, which is 365. We got 15. So the next step is we need to giving out blue squares, which is 5 tickets each. So we know that remaining tickets is 15. So we need to distribute 3 blue squares, which is 1 blue squares contain 5 tickets. So here we can see total tickets given is 15. So the remaining tickets is 0 because we minus it from the remaining tickets. So the total distribution is 50 plus 3 equals to 53 peoples. We move to the second scenario, which is we focus on 5 ticket pack first. So by distributing blue squares, we got 17 blue square. The total tickets given is 5 by 17 equals to 85. The remaining tickets, which is 365 minus 85, equals to 280. So then, by using yellow squares, we distribute it into 40. So each squares contains 70 cats. So 70 cats, we multiply it by 40 and we got 280. So the total distribution is 17 plus 40 equals to 57. So we have reached the final scenario, or the last scenario, which is we use all the three colors of packs. So first, we use yellow packs first, which is we start with 40 yellow squares. So 7 multiplied 40 equals to 280. So the remaining tickets is 85, because 365 minus 280 equals to 85. So then we use the blue squares, which is we give up 5 blue squares. So 5 by 5 equals to 25. So then we minus from the remaining tickets, which is 85 minus 25, we got 65. And lastly, we use the green squares. So by remaining tickets, we can get 20 green squares, which is each square have 3 tickets. So the total tickets given is 60, because 3 multiplied by 20 equals to 60, and we got the remaining tickets is 0. So total people for this scenario is 40 plus 5 plus 20 equals to 65. So we finally reach the last step in this polar methods, which is looking back or reviewing the solution. So from the result of the scenarios, we found a solution with 53 peoples, and the second scenario we found a solution with 57 people, and the third scenario we found a solution with 65 people. So literally the answer for this iconic representation, we got the number of people is 53, because of the we want a minimum number of people. So from the 3 scenarios, we got the smallest is 53, which is 50 receiving 7 tickets each and 3 receiving 5 tickets each. So to sum up, applying Polya's 4-step method to a non-routine numbers and operations problem demonstrates how an organized strategy can assist in resolving difficult mathematical issues. We could better connect with the mathematical concepts and develop our critical thinking skills by comprehending the problem, formulating a solution, implementing it, and evaluating the outcomes. This approach improves our comprehension of the issue and pushes us to consider several approaches. Additionally, encourage in the development of critical abilities that are helpful in addressing difficulties in real life, such as perseverance, creativity, and logical thinking. So I think that's all from me. Thank you for listening.